Welcome to my shop. Back in 2000 I bought this thickness planer brand new. It's a Delta DC380. The working capacity of this machine is 1/4 inch up to 6 inches. If you're anything like me, at some point you're going to want to be able to process material thinner than what this was designed for. So for me, what I did was I got curious to see how thin I could get with this equipment and have usable material. The short answer to that is I can get down to about a 32nd of an inch. And that's actually the mechanical limitations of this machine. By that, what I mean is the difference between the in-feed roller and the cutter head is right a little bit over 1/32nd of an inch. So I can process this down to where the in-feed roller is touching the table. If you're interested in knowing how I do this, stay tuned. Before I proceed any further, I'd like to issue a bit of a warning. Not all thickness planers are built the same. So proceed with caution whatever you do that's outside the manufacturer's design limitations of your equipment. Misuse of your equipment could lead to damage of equipment or personal bodily injury. So having said that, I'll continue on with what I've done with this and how I process material to get that thin out of this machine. A little technical information on this particular machine. It's a 3-horse motor, 15-inch wide capacity, go from 1/4 inch up to 6 inches, and it's got 2 feed rates. It's got 30 foot per minute and 16 foot per minute. I leave it on 16 foot per minute for what I'm doing today. For most of the things I do, I leave it at 16. It makes a cleaner cut with a slower feed rate. But processing real thin material, you need a slow feed rate. If you push it in too quick, you'll probably blow your material apart. One of the things I did with this machine is replace the original cutter head with one of the segmented cutter heads when they were available on the market. And we'll go ahead and open this up and I'll show you that. So what originally came with this machine was a 3-blade cutter head. Replacing it with the Helix head is a vast improvement. I'll zoom in and we can look at this. This has about 72 of these carbide cutters across here. They twist across the cutter head. If you nick one, you can either turn it. I'll zoom in, we can look at these a little bit closer. Looking at these individual cutters, you see this got 4 sides. Each one of these are sharpened, so if you do damage one of them or it gets dull, you can just turn it, set it back in place. So you actually get 4 cutting surfaces out of each one of these. Just makes life easier. The reason why I replaced this was kind of got tired of sending my blades out to sharpen and resetting them and all that. So it's well worth the investment to go ahead and replace the original cutter head on this machine with this Helix. In order to process thinner materials than what this machine will allow you to do, what I needed to do was have a thin material sled. This is made out of 1-inch MDF. I had some material that was formica on one side. It doesn't really need to be. The MDF will work just fine with no finish. I just decided to use it because I had it laying around the shop. This is made to fit in between the 2 tracks that hold your material in, and I've got 2 stops to bump up against that so that the sled doesn't get pulled into the machine while it's being used. In conjunction with this, I've made some positive stops, and I'll show you those in a minute, but there's a hole here to accept that, and I've got 2 different sets. I've got one set of positive stops to use without the sled, and then I've got a set to use with the sled. But what this sled allows you to do, it brings the bed up high enough so then you can go ahead and drop this You can literally drop this head down to where the cutter head will dig into this. You don't want to do that, but this is what allows you to go ahead and get those thinner materials passed through there. So we'll pull it in a little tighter and I'll show you how the positive stops work and a little bit about how I make them. Here's my set of positive stops. I made a block to hold them in. I've marked the size that this will process. I've got one side for my veneers to use with this sled, and I've got the other side for using without the sled for my other thicknesses, 1/2 inch up to 3/4 right here, and I've left room in here to add as I go along in case I add thicknesses to this. The other thing I did was I put a couple magnets in the base of this so that I can go ahead and leave it stuck to my planer and it's always available. So let's talk first about using these without the sled. What I did was I came in here and found a place that wouldn't interfere with the infeed. I went ahead and figured out what the distance is and what I can do. Once I set it, I can drop this on my positive stop and my material's always consistent. This just helps me in the shop. Every time I process something for 3/4, 1/2 inch, or 5/8, it's always the same. It doesn't matter if I process it this year, next year, a year from now. So using the veneer set with the sled, slide the sled in here. I've got an index hole right here, and drop this in, push it back, and it'll land up underneath here. This is in the area of the infeed, but typically if I'm doing anything veneer, I just keep it off to the side here, and it doesn't interfere with anything that I'm passing through there. You'll notice I've got significantly more positive stops for the veneer, and there's a reason for that, which we'll discuss in a minute. But this is how the positive stops work, either for the sled or with thicker materials right off the planer. These typically I try to do in increments not to exceed about 15 thousandths of a difference. I've got a couple gaps in here I need to fill in right now, but I go from 0.30 thickness of material down to 0.035, which is about a 32nd. And the trick to processing veneers is not to take too much material off at one time. Once I get down to 1/8 inch thick, 0.125 material, I typically start trying just to take those 10,000 to 15,000 shavings off of there. If you try to feed it in and take too much, it'll shatter your material. So that's part of the trick, and that's why I have so many of these. Not that I make a habit of going down to a 32nd of an inch, but that was just to see how thin I could actually produce veneers out of this machine. Now, making these positive stops, I've used 1/4-20 bolts, filed off the grade markings if there are any on the back to create a flat surface, and then after finding the distance I need for a piece of material, I use dial calipers and create the other ones off of that measurement. So it moves pretty fast after you find that first dimension. I like to start on the thicker material. That gives you a little bit of room. It's a little bit of a trial and error to, keep passing a piece of material through and measuring it until you get where you want. So, but that's the trick of this. Once you get that initial length, you can use your dial calipers and just grind down or file down the next one to where you need to be. I just finished running a variety of species through the planer to see what the result would be going down to a 32nd of an inch. Here's some cherry and poplar, 0.120, just under a 1/8 of an inch. It did fine, no tear out. This is some cherry and poplar. There was a little anomaly in the wood right here that it had some tear out, but all in all, 0.090, it fared well. I really didn't start having any issues until I was getting to 0.065 or below. The big difference is direction of feed on this. This is what will happen if you go against the grain. It just blew this out pretty bad, and that's why it's important while you have your material thick enough to tell what direction that grain is going. Obviously this was going in this direction. My cutter head was going in this direction. You can see where it just blew the big chunks of it out. If I had run this in the machine this way, it probably would have fared well, but that's just an example of wrong feed direction and what will happen. Here's some of the 0.050. Some tear out does start in the corner, and it seems to be consistent with where it starts. In the end, you probably lose 1.5 to 2 inches on this, but that's 0.050. It seems like once this end gets under the outfeed roller, everything processes real good. So you can compensate for loss right there. You still have a good piece of veneer you can use at 0.050. Here's some maple. This actually didn't have any tear out at all, and it fared well. I mean, the center of the knot was gone on this before, but it actually didn't blow out anymore. 0.050. Here's a piece of poplar, beginning of tear out right on that corner, still a usable piece. Here's a piece of cherry. It blew out a little bit more, but like I said, 2 inches on that and you're good. Here's another piece that didn't blow out at all at 0.050. Another piece of poplar, just a little bit in the end, and same here on this poplar. Now, going down to 0.035, here's a piece of hickory. There was a little knot sort of thing in here that it tore out, but all in all, it fared well. Piece of cherry, it didn't blow out. Here's a piece of the maple, lost about 2 inches on the end, but the rest of it fared very well. And then here's the poplar, and I lost about 3 inches on it. So, and then here's some mahogany. This piece, this is some stuff that I had resawed on the bandsaw. It went through this piece, 0.035 thick, just lost maybe 1 inch off the end of that. And this was probably wrong feed direction, and it blew out some of this. I flipped it around and took another pass on the other side, and there wasn't any more tear out on that one. So all in all, that machine will go down to about 1/32 of an inch, and you can produce usable veneer. Don't know if you need it that thin, but that's what that machine can produce. So a couple of factors in doing that. One is the segmented cutter head. I think that's a big difference. I don't think that you could do this that thin with the straight blade cutter heads. Material is a big difference also. I would not try to run figured material through there. It'll blow it out, I'm pretty sure, just by example of the small places on some of this material. But if you're using straight grain material, you probably do pretty well at it. The other thing is make sure you know the direction of feed. I showed you the example of what will happen if you go against the grain. It'll blow it out real big. And the key, I believe, to running this material that thin is having positive stops at increments that are a 10,000th difference and stepping that down. I start at about an 1/8 inch, you can probably start thinner. If you're resawing and you can resaw your material at 0.08, you can probably finish it off through there, just taking those incremental steps. This is 0.08, 0.065, 0.050, and 0.035. And that's critical on taking just those really light shavings off. If you go in there and try to go from an 1/8 inch down to 0.065 or 0.08, it's trying to hog off too much material and it'll tear everything up. Thicker material, you can take bigger increments out of it while you reduce it, like up in the range from 1/4 inch down to an 1/8 inch. But going from that 1/8 inch down to a 32nd of an inch is real important to keep those increments in line and don't skip one. So I hope this was helpful. If you have the inclination to go ahead and run veneers, a lot of times you may not need anything that thin, but even getting down to a 1/16 of an inch or something can be a challenge on a planer. And like I said, when you're using your equipment, know it very well. Not all planers are the same. I don't know if this would work in a benchtop planer. I've only had that 15-inch Delta. That's what I'm used to, and I've learned how to work around it. And these positive stops will help you with, regardless of what your planer is, on whether you're running 1/2 inch material, 3/4 material. If you have a set of these sitting at your planer, just a helpful tool to have at your disposal. So I hope this was helpful if you want to do this, and I hope to see you on the next video. And what I'm going to do now is I just run the video of the machine making all the passes for this material so that you can see what my process is. I'll just speed it up because I know most of you don't want to sit there and just watch that. If I was helpful and you're not subscribed, go ahead and subscribe, and at least give me a like. And I appreciate you watching. See you on the next video.